In number 7, again, this is the same problem, but we're being asked to think about this on a graph. Remember that the y-coordinate, if I know the y-coordinate, that's denoted by f of x. So the y-coordinate that goes with the input x is called f of x. And so what we're really asking here is when is f of x, which we have a formula for, right? That's the formula for f of x. When is that equal -4? And so remember, that's what this equation means in this formula, f of x equals whatever. F of x stands for the y-coordinate on the curve. And so if you know the y-coordinate, that means that you're saying that -4 should stand in for f of x. And the question is, what are the possible x's that do that? So basically, we're trying to find the x's that make this true. And so I use the same strategy again. I want to get 0 on the right-hand side. I want to give it a second to try to factor it. In this case, it does factor. I need two numbers whose product is 15, whose sum is 8. That's easy. That's just 5 and 3. And so for the product, x plus 5 times x plus 3 times x plus 5 to be 0 means that either x plus 3 is 0 or x plus 5 is 0. And so my two solutions, I'm trying to find possible x-coordinates. It doesn't want the point. It wants just the x-coordinates. So the possible x-coordinates are -3 and -5. In number 8, this again is just getting back to, this has nothing to do with this unit. This is going out through the whole course. So remember, f of 3 means the y-coordinate when the x-coordinate is 3. Right? That's literally what f of 3 means, and it doesn't matter what the picture is. So on the graph, if you locate x equals 3, which is here, that's the x-coordinate of 3, that's the point on the graph. The y-coordinate of that point is -3. So the answer to this question is just -3. Again, graphically, we're looking for x and y-intercepts. So as long as we know what that means, x-intercept means the point on the x-axis, the y-intercept means the point on the y-axis, and it says write my answers as points, and so I want to do that. So the x-intercept, there's just one. It's 1, 0, right? There could be several x-intercepts, but in this case, the graph only touches the x-axis at one point. And then the y-intercept, there's only going to be one of those. In this case, it's 0, 1. The vertex of the parabola, remember when we think about this in terms of a quadratic formula, we think of A as 1, B as 2, and C is -3. But we can use that same the same letters to find the coordinates of the x-coordinates of the vertex. The x-coordinate of the vertex is just -b over 2a. So remember, that comes from the quadratic formula. That's the first part of the quadratic formula. It's like the quadratic formula if you erase the plus or minus stuff, like the ugly stuff in the quadratic formula. If you erased all of that, this is what you're left with. And that's actually not a coincidence. That's exactly how the quadratic formula works. The quadratic formula basically finds the x-coordinate of the vertex of the parabola and then goes out left and right the same distance because of symmetry to find the x-intercepts. So anyway, so it's not so surprising that the vertex is halfway between the two intercepts, is what that basically means. Anyway, so it's an easy formula. So b is 2, so this is -2 over 2, so -1. I want my answer as a point, not just an x-coordinate, so I need to know the y-coordinate as well. So the y-coordinate is just going to be f of the x-coordinate, right? It's what I get when I put the x-coordinate into the formula. And so if I do that here, I'll have 1 minus 2 minus 3, which is -4. So my answer as a point is -1, -4. So on a graph, I can picture where that is on a piece of graph paper. That's going to be the vertex, the bottom point of this this opening upward parabola. Okay, so that's all of the quadratic equation problems, or quadratic function problems on this gateway. The rest of the problems here are going to be about general polynomial functions, which is covered in section 5.1. Factor completely, well, the first thing we do when we factor is we look for a common factor for every term, and so in this case, 5t squared goes into every term. You can see that each of the numbers in this polynomial, all of these are multiples of 5, and there's at least a t squared in every term. So that's an easy thing to pull out. That'll leave me behind a t squared minus 12t plus, and I got to think about what 175 divided by 5 is. I guess that's 35. But that's not factored completely because the thing in parentheses is now a quadratic that can also be factored. So to factor this, I need a product of 35 and a sum of negative 12, which negative 5 and negative 7 will do that. So I'll have 5t squared times t minus 5 times t minus 7 is my complete factorization. So, and don't forget, you can check that. It's easy to multiply out. You have FOIL for the two binomials being multiplied together, and then multiply the 5t squared through. Solving the equation is what we do with factored form. So we know that if you have written something as a product equal to 0, then right away I know that one of the pieces should be 0. And so if I want to be, pedantic about it, I would say it's got to be one of these factors. So so I know that that this polynomial has three things multiplied together equal to 0. Negative 2 is never equal to 0, obviously. X minus 8 squared equals 0. Well, the only way that can happen is if x is 8, right? The power doesn't really matter there. The power of something being 0 just means that the thing is 0. Or x is negative 3. So if you have a factored form originally, knowing that the product equals 0 means that something in the product is equal to 0. And so you can attack each of the separate terms separately. Seem to have lost answer blanks at this point. Anyway, so the solution set here is it's negative 3, 8, are the two solutions. The x-intercept means where is the y-coordinate equal to 0. So the x-intercept is just exactly when f of x, which is equal to this formula, is equal to 0. So that's how you're going to find the x-intercepts. So just like before, the only way that you can have a product equal to 0, I'm not going to worry about 2 being 0, that's just dumb, is if one of the terms is 0. So the only way you can have x plus 1 times x plus 5 to the 4th equal to 0 is if x plus 1 is 0 or x plus 5 is 0, which means that x equals, negative 1 or x equals negative 5. So the x-intercepts here then, it doesn't say to write these as points, so I guess either way is okay, but here they are as points. Two x-intercepts are negative 1, 0 and negative 5, 0. Now this part about specifying whether the graph touches or crosses the x-axis, that has to just do with the power of the term in the polynomial. So the term in the polynomial that gave us the negative 1 intercept is this term, and this term's power is 1. So that's an odd power. The x plus 1 occurred to an odd power, and so at this intercept, the graph crosses the x-axis. By contrast, the x plus 5 here is to an even power. And so if you have a factor raised to an even power, then at that x-intercept, the graph is only going to touch the x-axis. So the rule we have is that each of the factors gives us an intercept. if the factor has an odd power, is raised to an odd power, then the graph crosses the x-axis at that intercept. And if the factor has an even power, then the graph just touches the x-axis at that intercept. Don't forget the y-intercept is easy. That just means the x-coordinate is 0. And if you have a formula for a function, putting the x-coordinate equal to 0 is easy. That just means f of 0. So f of 0 is 4 times 0 minus 4 cubed times 0 minus 1. And so if you do that, that's 256. Again, this doesn't say whether it wants it as a point or not, but as a point, this would be the point 0, 256. And finally, we have this this big-ass graph for number 15. So I can tell from analyzing the factors here that I'm going to have x-intercepts at -2, 0 and -6, 0. So that's what's going to happen for the x-intercepts. My y-intercept, and it's going to, both are going to cross the axis. Notice the powers here are both odd. This factor is to an odd power, and this is to the first power. So the graph should cross cross the axis at each of those places, not touch. And I also know the y-intercept is 0, let's see, what is that? 0 to cube is 8. 8 times 6 is 48, times 0.2, so a fifth of 48 is like negative 10 or so negative 9 point something. And so, so just knowing those points, knowing the intercepts and the behavior at the intercepts, usually we'll be able to let you know which one of these things this is. If you look, this is the only one that actually does all of those things. Oh, no, it doesn't. Sorry, looking at the wrong thing. This is the only one that does all of those things. So we have the x-intercepts there and there. The graph is crossing the axis at those places, and the y-intercept is around -10 or whatever it is. Notice I don't really care exactly what the y-intercept is because of the scale here, but knowing that it's about +10 or about -10, right, that's really the main thing. None of these other graphs do that. This one has the wrong x-intercepts. This one has the wrong y-intercept, and this one has the wrong behavior here. It's just touching instead of crossing. So just from the simple analysis we've done, that one is the right graph.